Hello everyone, I'm Paul and today we're solving problem 1290, convert binary number in a linked list to integer. This one is easy, so here I will show you my thought process and efficient solution. We are given a linked list which holds the binary representation of a number. Here you can see an example. And we need to return the decimal value of the number in the linked list. And this is very important. The most significant bit is at the head of the linked list. So for example, if we are given this, 101 in binary equals to 5 in decimal. Now, in case you know, in this position, we do 2 to the power of 0. Here we do 2 to the power of 1. And here we do 2 to the power of 2. And if we take 2 to the power of 2 times 1, we have 4, plus 2 to the power of 1 times 0, 0, plus 2 to the power of 0, this is 1, times 1, 1. And if we do 4 plus 0 plus 1, we have 5, which is this 5. So this is how we transform a number in binary to a number in base 10, meaning in decimal value. Now, of course, we can extend this. Let's say we have more digits here to the left. Here we will have 2 to the power of 3, 2 to the power of 4, and so on. Now, going back to the problem, we are given this linked list. And the head of this linked list is here. And the problem here is that we read binary from right to left. So we need to read this from right to left. But we are iterating this from left to right. So there are many ways to solve this, and here I will show you two. For the first approach, we have an array, and this array is initially empty, and we are iterating this from left to right. And each time we are adding the current value to the array. So we start from here and we add 1 to the array and we continue. Now we are here, so we add 0 to the array and we continue. Finally we are here, so we add 1 to the array. So now we have the binary number in an array and the result is initially 0. And we are iterating this from right to left. So first the I pointer is here, we can say this is position 0. Now we can say result is this, bitwise, or 1 left shift the current position, meaning 0. Now let's analyze this. In case you know what left shift is, let's say we have a 1, and this means we are shifting everything one step to the left. So we apply this operation and now we have the same 1 because we are left shifting everything 0 times, so we have the same number. Now in case you know what this is, let's say we do 0 or 1. And here if we have a 1 in any of both sides, the result for this is 1. In this case we have a 1 here, so the result is 1. So the result is currently 1 in base 10. Now the I pointer is here, we can say this is position 1. Remember, we are going from right to left. And now we take the result, or the current value, meaning 0, left shift the current position 1. And this is 0, 1 step to the left. So this is 0, 0, which equals 0. So if we do 1 or 0, this is still 1. So the result is still 1. Now we are here and we take the current result or the current value 1 left shift the current position, meaning 2. And this is 1, 2 steps to the left. So this is 1, 0, 0. Okay? We are filling empty spaces with 0. Now if we do 1 or 1, 0, 0, here we have a 1 and a 0, so the result is 1. Here we have a 0, and here we have a 1. So the result in binary is 101, meaning 5 in base 10. So we return this. Now let's go with the code, and next I will show you a second approach. First, we need the array to store numbers. We'll call this num. This is initially an empty array. Now we can iterate the linked list. So while we have a head, remember we are iterating this linked list from left to right. So at each step we will say head is head dot next. And before this we need to add to the array, meaning num.append, the current value head.val. So now the result is initially 0. We have an I pointer which is initially 0, and for every value in the number, but we can reverse this. We can reverse an array like this in Python. And now we can say result or equal x left shift the current position, the current I pointer. And next we update the I pointer, so I plus equal 1, and we return the result. So this is just one way to solve this. Now let's submit this and see if it works. As you can see, this works, and this is very efficient. Here I'm using OR, but you can also use a plus here. This works the same. I will submit this just to show you this also works. And as you can see, this also works. So now I will show you a second approach. Now let's say we are iterating this again from left to right. So first we are here, and the result is initially 0. And each time we will move the current result one step to the left, meaning we do this left shift 1, and we add the current value. Because remember, the problem here is that we are reading linked lists from left to right, but we are reading binary from right to left. So for this approach, we are moving the result to the left as we are reading this from left to right. So first we have 0, 0, left shift 1 is 0, 0, meaning it's still 0. Now we need to do this or the current value, and 0 or 1 is 1. So the result is now 1. Now we are here, so we do result left shift 1. This is 1, 0. We are moving this one step to the left, and we add 0 for new positions. So now we have 1, 0 in binary. And now we need to do this or the current value, meaning 0. And 10 or 0 is 10. So the result right now is 10 in base 2, meaning 2 in base 10. Here you can see how we are on the right track. The current result in binary is 1, 0. So we are reading this in order. So we are good to go. Next we are here. Remember 2 in binary is 10. And if we do this left shift 1, we have 1, 0, 0. Now if we do this or the current value, meaning 1, we have 1, 0, 1 in binary, and this is 5 in base 10. So we return this. Now the key for this approach is that we are iterating values in this linked list from left to right, and at the same time we are shifting the result one step to the left each time. So now let's go with the code, and hopefully you will get the idea. This code is very short. First the result is 0. Now we can say while we have a head, we do head equals head.next. This is how we iterate the linked list. And before doing this, the new result is result left shift 1 or the current value head.val. And finally we return the result. So this is it for the code. Now let's submit this and see if it works. As you can see, this solution works, and this is also very efficient. Time and space complexity for the first approach is big O of n, and for this approach, time complexity is big O of n, and space complexity is big O of 1. So this solution is slightly more efficient overall. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.